Hello viewers, Alan here, welcome back to the workshop. A few weeks ago I did a project where I needed to drill into the end of a bolt so I could put a brass pad in there. This was so that the brass pad wouldn't mark what it was pressing against. It wasn't the easiest of things to do because getting hold of a brass a bolt by its hex head, it's not the easiest thing. And it got me thinking, well, what's a good way to do that? I was aware dimly of things called lantern chucks, which grab hold of screws and things to allow people to work on the threads, but I hadn't actually seen one for a hex head bolt. They may exist, but I didn't see one. And so I thought, well, let's see what I can come up with. So I got the CAD out, CAD software, and come up with a prototype. So in my thinking, I've got a body or a shaft with a drive dog, and a collet which engages on the end of the dog, and a hole through that, and a 90-degree slot which matches the size of the bolt which this thing is to hold. And I have actually successfully made that in steel, and well, perhaps you'd like to see how I did it. To cut the hexagon flats on the outside of the nut, I need to use the rotary table and attached chuck. This lot weighs about 50 kilos, so it's a bit much for me to be hefting around at my stage. So I've got this lifting arrangement. So I'll just lift it up a bit more to make sure I've got clearance over the table. So the purpose of this lever will become a bit clearer now, as it lets me lower I use the coarse feed of the hoist to get the thing somewhere near the table, and then I can use the controlled slow movement to lower it down, and then let the lift off. Okay, set up to go. It's all bolted down and lined up. This is a bit of it's hot rolled but free cutting steel. It's 42 diameter, and I want to produce a nut which is 34mm across the flats. So I'm going to do a 2mm depth of cut on 6 faces to start with, and then measure up, and I can start getting a bit more accurate about how much to take off. And the nut needs to finish up 31 or so long. Okay, that's the first pass, so we'll go around 60 degrees. Okay, let's see what we finished up with across the flats. So perhaps you can see we landed on 37.14, so I've got to take 1.57 off each of the faces to finish up on 34. The exact dimension I'll finish up with isn't really important because I'll be using an adjustable spanner anyway. Some big burrs. I'll round these corners off in due course, but I just want to make it safe to handle in the meantime. Right, it's a little bit rough and ready, but certainly good enough for an adjustable spanner. Yep, so it turned out pretty much on size, so I was shooting for 34, and 34 on that pair. .96 on that pair. Spot on with that pair. So I'm happy with that. Certainly good enough for a set of spanner flats. Set now to put this is a 17mm drill, and then I'll be boring that out to 20. That should be a bit more than I need. So I do have a set of reduced shank twist drills, but when I'm over 1/2 inch, if I get the chance, I'd much rather use a Morse taper drill. They just don't twist in the chuck or otherwise mess about. So I want to bore this out to 20. I've done one pass to 18, so this second pass will be to 19. The exact diameter here isn't critical, it's just a clearance hole. Felt a bit funny at the bottom of the hole, but the tip looks alright to my half-blind eyes. So we're on 18.99. Okay. Well, we're on track to hit 20 anyway, which is what we want. Now that should have been the final pass to get me pretty close to 20. I'd call that pretty close to 20. So that 20mm bore will go right through the nut, but now I've got to do a follow-up bore at 25 diameter, which will leave a too thick layer at the end. What I was originally shooting for was a M27 1.5 pitch thread here, which is a special home brew, and a 25mm clearance hole at the end. But actually the calculated minor diameter for M27 1.5 is 25.16, so I think I'm just going to bore this out to 25.16 to within 2mm at the bottom, which means going in 28. Well, let's see how close that came to 25.16. Oh, what? I don't know whether you can read that. That's exactly 25.16. So we're on the calculated minor diameter for my M27 thread, but I do need to put a run-out groove at where the thread will end. So I think I'll make this run-out groove 4mm long. Three. Let's make it 3. What's the? Yeah, it's not a very good cutter for doing that, is it? What else have I got? And I think I might have found just what the doctor ordered here. That's 3.3 wide, and yeah. So if I pull that towards me a millimetre, job done. Looks like I forgot to press record. Anyway, it looked like it was cutting quite nicely in pretty good chips. So we'll just clear the hole out. Now you're not going to be able to see this, but I'm not sure I could see it either. I should better fill the groove with that, shouldn't I? Oh yeah, it's there, just hard to see. Alright, well, I guess I've got to rely on the DRO that at the bottom of that groove is 27, so my thread cutter can run out into it. I guess we'll find out. Okay, so we're set up to start cutting this internal thread, and I always get nervous doing these things. Fingers crossed. Alright, I can engage the half nuts anywhere because this is a 1.5mm pitch, and it's a factor of my lead screw pitch. Okay, so this is the final pass, bringing my thread out to 27mm. Alright, well, we've definitely got a thread there. And whatever it is, I'll be making the male to match it. So we just get a bit of a chamfer on this end of the thread. Yeah, I think that'll be fine. I've just got to knock these corners off now. Well, I think that looks alright. Not sure how the camera's picking that up, but that looks pretty good. And I part this guy off at 31 long, so I've got a bit of clean up on the back side. Getting pretty close now. Right, I don't know how much heat got into that. Probably not a lot, but we'll treat it with caution anyway. Right, let's clean this end up. I've got to take 0.55 off it. I'll do that in 2 passes, so this is 0.4. And whatever that is where we're leaving it. It's just to try to make sure that this bottom face is about 2 millimeters thick. And that looks about right to me. Right, let's clean these corners up. Another millimetre, I think. It's finished making this nut. I'll just touch that with the file and the Scotch-Brite. Right, so I'd say that nut's finished. Got a bit of a clean up inside. So I've moved on to making this bit now. So, first move is to face that off. This has some eccentricity, which you probably noticed when I was doing the facing. So I'll do a first pass at 30 and get the DRO calibrated. This has started squeaking for some reason. I'll just go and check the tip out under the microscope. So the insert does have a small chip. So that was set for 25.5, but with the new insert and a different depth of cut, we've got 25.423. Right, that should be somewhere close to 25. Right, I guess that's pretty close. Yeah, that's fine. It means my thread cutter has got somewhere to run out. Right, I've just realised if I cut the thread from this side, I can't test fit it. So I'm going to have to cut this off, turn it around and cut the thread from the other end. So I better deal with that corner, since I'm going to have to catch this thing. So I want to part it off at 55. Right, so we start cutting my 27mm thread here. I'm going to start my first pass at 26.5, I think. and it's up the end of the nut here now. So I reckon that's a done deal. Right, so really only thing left to do here is to mill the drive dog on the end here. And I have to decide whether or not to put a hex pattern on the end here as well. And I don't need to, because I always put it in a collet block, but we'll have to think about that. So set up here to mill the drive dog on the end of the shaft. The dog needs to be 6mm wide or thick, I guess. The shaft's 25mm, so I've basically got to take 9.5mm or thereabouts off each side of the centre line. So I did that with several roughing passes, 3mm each, and then switched over to doing some finishing passes. Okay, this should be the final pass. Very light skim on the vertical and just bringing this down to depth. I think they'll be fine with a bit of deburring. There's the tradies next door. I'm daring to hope those tradies will be finished by Christmas. After 3 years with the various building projects beside us. Pretty hefty burr on there. I think that's got it. I'll finish off the rest of that deburring and I can get it a bit more easily. So hopefully this guy will now fit. Yep, happy with that. Quite happy for it to be a snug fit. So in this setup I'm making one of the collets with the intersecting cuts. One cut is for the drive dog on the end of the shaft and the other's for the bolt head. So that's finished the 6mm wide slot for the drive dog, and this collet is going to be for a 5mm bolt, so the slot going the other way to accommodate the bolt head will be 8mm wide. So I'm using an 8mm cutter for this slot and I've got to go 10 deep, so I'm going to try to do it in two 5mm passes. We'll see how well that works out. I might be asking too much of the cutter, I'm not sure. Well, the cutter seemed to cope with that alright, didn't it? I think it's on the limit, but it managed it. So we'll go back and do the second pass. Well, that seemed to work out alright. Alright, time for a big clean-up. Right, I'm parting this guy off now, leaving a 2mm thick base. Hopefully that'll be enough. It's a bit experimental. We'll find out. Right, let's pull that out and get it cleaned up. Right, finished making the pieces. Let's see if they'll go together. So we've got the nut, got the shaft with the dog on the end, drive dog on the end, and the hex on the other to grip it while we're doing the nut up, and one of the collets with a 5mm bolt in it. There you go. Just take them over to the vise, nip that up, then I'll go and put it in the lathe. I'm going to have a look at the run out of a typical bolt. I've put it in the 3-jaw. That's a 5mm bolt, and we'll see how much run out we get. So I'm quite pleased with that, without putting precision measuring equipment on it. I'm not sure how you'd do that anyway. The run out looks quite modest, and it's certainly good enough for the two things I had in mind, which is dog pointing a screw maybe, you know, just cutting all the threads back and having a plain shank to engage in the groove, or alternately, as I had to do recently, drilling the end out to take a brass insert so that when you do the screws up it doesn't damage what it's doing up against. So I think it's going to be good enough for both of those jobs. Actually, I realised that I could check the run out objectively because I've got a dial gauge that I can fit a big foot to. So that foot's now riding across a number of threads at the same time, so should give a reasonable readout and show just how bad this is. Well, I'm pretty pleased with that, I can tell you. 0.1 run out, given the situation. I mean, who knows how concentric the threads were to the bolt head in the first place, but that chuck is obviously holding it pretty reasonably. I'm quite pleased with how that turned out. It's another case of starting with a CAD model, prototyping in 3D printing. And I actually decided to make 4 collets to start off with. There's one for 5, 6, 8 and 10mm bolts. Some of those would double up for imperial sizes, but the collets themselves are pretty simple. There's just a disc with 2 end mill cuts across it, so pretty quick and easy to make more if needed. Yeah, and I'm quite pleased with how it all goes together. The bits fit quite nicely. And the one I tested the run out on, as you saw, was surprisingly good. I haven't tested the others. I dare say some of them might not be as good, but for the job of drilling a hole in the end to put a pad in or dog pointing it, I've got a box full of bolts. I'll just find one that runs fairly well. They don't all have to run perfectly. So all in all, it's a pretty easy project to do, and I've knocked out some drawings for myself, and yeah, it's probably not something I use every day, but it's just an interesting project to do. Anyway, if you made it this far, I hope you found it entertaining and got something out of it, and hope to see you on the next one. Cheers.